Today's objective is that we are going to rationalize both monomial and binomial denominators. You notice this is part 1 of a video, and part 1 is just going to focus on monomial denominators. So all these examples have just a single term on the bottom. They're all irrational radical expressions. When we're done with each of these, the denominators are going to be rational numbers, meaning instead of like square root of 13, it'll just say 13. So the way we do this is by using this cool little trick. You can take a number, any number, and multiply it by 1 and it doesn't change anything, right? Similarly, you can take a number and multiply it by something that is equivalent to 1 and it still won't change anything. So I wrote root 5 over root 5. Anything divided by itself is 1. So this is also true. A times 1 is A. Now, in this case, I can take 7 divided by root 13, and what we do is we multiply it by whatever the denominator square root is over itself. So root 13 over root 13. Now again, the reason we're doing this is that technically we're just multiplying this expression by 1, and that doesn't change anything. So what we get here is 7 root 13 in the numerator. And then in the denominator, we have root 13 times root 13, and that is root 13 squared. There's 2 of them. And you know what happens if you have a square root and a square at the same time. They're inverse operations, so they cancel each other out. So to finish this problem, we have 7 root 13 over 13. You notice that our denominator is no longer an irrational number. It's now a rational number. And these expressions are equivalent. If you type this into the calculator, and if you type this into the calculator, you will get identical answers. Next example, 3 root 5 over root 2. Just like this one, we're going to multiply by whatever the denominator root is over itself. So root 2 over root 2. This gives us 3 root 5 times 2, so because both of these are inside the square root, the 5 and the 2, they multiply together, divided by root 2 squared. Just like last time, the square root and the square cancel each other out, and so our final answer here is going to be 3 root 10, the 10 came from the 5 times 2, divided by 2. And that is it. If this seems easy to you, it should be. Once you get it, these problems tend to go pretty fast. Last example, 18 root 5 over root 6. So by now you should know what we're doing. We're going to multiply both the numerator and denominator by root 6. So root 6 over root 6. This gives us 18 times square root of 5 times 6 divided by root 6 squared. Square root and square cancel each other out. And the 5 times 6 is going to give us 30. So we have 18 root 30 divided by 6. And there's only one more thing to do here. If the numbers outside of the root simplify, then you should simplify them. So in this case, 18 divided by 6 does indeed simplify to 3. So our final answer here is just 3 square root of 30. And that's the answer. The only thing I want to point out about this is as I did these examples, I probably showed more steps than you need to. So when you get more comfortable with this, you probably don't need to write 5 times 6 and root 6 squared if you know where it's going. These problems should be going pretty fast for you. So that is it. Today our objective was to rationalize both monomial and binomial denominators. And for this video we just did monomial denominators.